In this video, I will continue the topic number systems of chapter number 1, data representation, from section A of your book. Now, according to your O-level computer science syllabus, you need to understand that how and why computers use binary to represent all forms of data. In previous video, we have done that why computers use binary to represent all forms of data. Now in this video, we will continue part of this task, that how computers use binary numbers to represent all forms of data. As we know that computer is a digital machine, it uses digits to perform all its functionalities. And the numbering system that a computer adopted is the binary number system. And it has been previously mentioned that binary number system based on two numbers, and these two numbers are zeros and ones. On the basis of these two digits, computer perform all its functionality. And computer use binary numbers to represent all forms of data. This form of data can be in numeric quantities such as numbers, can be in alphabetic letters such as A to Z, either in uppercase or either in lowercase, and symbols such as punctuations. All these are represented inside a computer system by a specific pattern of zeros and ones. Now, in order to understand that how computers use binary numbers to represent all forms of data, you need to know that for each printable character, there is an ASCII code. This ASCII code includes the digits 0 to 9, alphabets letters either in uppercase or lowercase, and the punctuation symbols. This ASCII code stands for American Standard Code for Information Interchange, and this is basically a character encoding standard. When a user types any character, so there is an ASCII code for a particular character. This ASCII code converted into a specific pattern of zeros and ones, and this pattern of bits is understandable by a computer system. For example, when a user type a 1, so there is an ASCII code 49 for a numerical value 1. Or when a user type a letter alphabet A in uppercase, so there is an ASCII code 65 for alphabet A. Or if a user type a symbol like punctuation, percentage, so it has an ASCII code 37. This ASCII code converted into a specific pattern of zeros and ones. Now here we have completed task number 1. Now move to the task number 2. In part A, understand the binary, denary and hexadecimal number systems, and in part B, here is a conversion between number systems in both directions. Remember that base or radix defines number of digits that a number system has. Means if a binary number system has base 2, so it means there are only two numbers, and these two numbers are 0 and 1. Same as if a denary number system, which is also called decimal number system, has base 10, so it means numbers 0 to 9 are used in decimal number system. So that's why it has base 10, because if we count 0 to 9 numbers, so it will be 10. And same as hexadecimal number system has base 16, so it means that it consists of 0 to 9 numerical values while A to F alphabets. So if we count these numeric values and as well as alphabets, total will be 16. So that's why hexadecimal number system has base 16. Now move to the part 2 of task number 2. But before getting started, remember that binary numbers can be signed or unsigned. And if I talk about the unsigned binary numbers, these all are positive. We don't need to use terms like positive and negative for unsigned binary numbers. But if we talk about signed binary numbers, so signed binary numbers can be positive or negative. But how we can judge whether it is positive or negative? In 8-bit binary register, the leftmost bit is called MSB, which stands for most significant bit, while the rightmost bit is called LSB, which stands for least significant bit. And the leftmost bits represent the sign of a binary number. If the MSB is 0, so it means binary number is positive. If the MSB is 1, so it means the binary number is negative. So hope you understand. Now let's move to the part B of task number 2, in which we need to convert the positive binary number into positive denary number. Here the question is given in binary form, and you just need to convert this positive binary number into positive denary number. There are some steps for the conversion. The first one is write each binary digit exactly the same with some gaps. And under each binary digit you just need to write 2, because binary number has base 2. And remember, each binary digit position has its weight value, and these weights value are parts of 2. So we need to write positional value, and in binary number system these positional value go up in parts of 2. And now we need to write value for each part of 2. And you know, anything that has power 0 will be considered as 1. So here 2 has power 0, so it will be 1. And same as 2 to the power of 1 will be 2, 2 to the power of 2 will be 4, 2 to the power of 3 will be 8, then 16, then 32, then 64, and finally 2 to the power of 7 will be 128. Now we just cross out a value under a 0. So here is 1, so we will not cross out 1. Here is 0, so we will cross out 2. Here is also 0, so we will cross 4, and then we will cross 8, and then we will not cross out 16 and 32 because we just need to cross out a value under a 0. And here is 0, so we will cross out 64, and finally here is 0, so we will also cross out 128. And finally we will add these positional values. So if we add 32 plus 16 plus 1, so it will be 49, which is a decimal equivalent of this binary number. Now this is the conversion in one direction, but we need to convert this number in both directions. Here is a method to convert the positive denary number into a positive binary number. Here is a conversion of positive denary number into positive binary number, and after you know how it is done, you will be able to understand the concept of computer registers. Now before getting started, remember, binary numbers are 0 and 1, and decimal numbers are 0 to 9. And decimal and denary both are same. I may use both terms either interchangeably, so don't get confused if I use decimal in place of denary and denary in place of decimal. Here is a conversion of this base 10 number into base 2. How we will do this? Let's divide this decimal number by the factor of 2. So here the number is 66, and we will divide it repeatedly by the factor of 2. Here 2 divided by 6, so it will be 33. So the remainder will be 0. Repeat this again. If we divide 33 by 2, it will be 16, and the remainder will be 1. And then when we divide it again, so it will be 8, and the remainder will be 0, and it will be 4, and the remainder will be 0, then 2, and the remainder will be 0, and finally when we divide 2 by 2, so it will be 1 and the remainder will be 0. Remainders read upward, and when we read remainders upward, so these are binary equivalent of the denary number. But if we count these remainders, so these are 7, but in your exams you need to convert into an 8-bit positive binary register. So if we will write these remainders into an 8-bit binary register, so write these remainders from upward to downward from right hand side. So it will be 0 1 0 0 0 0 1. Here is an empty place in 8-bit binary register. How you will fill this? So just write 0 in an empty place in order to make an 8-bit binary register. And you know, if MSB is 0, so the number is positive. So here we have done the conversion of positive denary number into positive binary number. Stay connected with the channel, like and subscribe Learning Factor, and learn a lot.